Magnetic separation. Magnetic separation method is based on magnetic and non-magnetic properties of two components of ore. The ground ore is carried on a conveyor belt which passes over a magnetic roller. The non-magnetic particles leave the belt and fall off from it. The magnetic particles are attracted by the magnetic field and form a separated pile. This method is used to remove ore particles from cassiterite, magnetite, chromite, and pyrolusite. Froth flotation method. This method is generally used for the concentration of sulfide ores. The principle behind froth flotation process is that sulfide ores are preferentially wetted by pine oil, whereas gangue particles are wetted by water. In this process, a suspension of a powdered ore is made with water. Collectors like pine oil, fatty acids, and xanthates are added to it. Froth stabilizers like cresols and aniline stabilize the froth. The mineral particles become wet by oils while gangue particles by water. A rotating paddle agitates the mixture and draws air in it. As a result, froth is formed, which carries the mineral particles. The froth is light and is skimmed off. It is then dried for the recovery of the ore particles. Extraction of crude metal from concentrated ore. The concentrated ore must be converted into a form which is suitable for reduction. Oxides are easier to reduce. Thus, isolation of metals from concentrated ore involves two major steps: conversion to oxide and reduction of oxide to metal. Conversion of oxide. It is easier to reduce oxide than sulfide or carbonate ore. This can be done by two methods: calcination and roasting. Calcination. It involves heating when the volatile matter escapes, leaving behind the metal oxide. Roasting. It is a process in which ore is heated in regular supply of air at a temperature below the melting point of the metal. Sulfide ores are converted into oxide by roasting. Reduction of oxide to metal. The process of converting metal oxide into metal is called reduction. It needs a suitable reducing agent depending upon the reactivity or reducing power of the metal. For example, carbon, carbon monoxide, aluminium, and magnesium. Example on extraction of crude metals. Let's take an example on extraction of crude metals. Describe the principle of extraction of each of the following: Sn from SnO2, Zn from ZnO, Cr from Cr2O3. Let's see the solution. Sn is obtained from SnO2 by using carbon as a reducing agent. Sn is a less reactive metal. Zn is obtained from ZnO using CO as a reducing agent at 1600 Kelvin. Cr is obtained from Cr2O3 using aluminothermic process.